A local newspaper reports a confidence interval as 0.447 plus or minus 0.052. Express this confidence interval in the following alternate forms. First, interval notation, and then using inequalities. Let's begin by defining the numbers that we were given. First, the 0.447. This first number is called the point estimate. This is the number that our confidence interval is based on. The number after the plus or minus, the 0.052, is called the error. Now, in order to find the lower bound and upper bounds, the lower bound is the point estimate minus the error. Whereas the upper bound will be the estimate plus the error. We'll enter this into Excel. First, the estimate and the error. The estimate was 0.447 and the error was 0.052. To get our lower bound, we'll say equals, we click on the estimate and subtract the error, taking B7 minus B8. And the upper bound will be the estimate plus the error. So our lower bound is 0.395 and our upper bound is 0.499. Now, in interval notation, we write this inside of a pair of brackets. We'll write the lower bound first and the upper bound second. Using inequality notation, we'll have to write the lower bound, then less than p less than upper bound. So we write 0.395, a less than sign, the letter p which we were given, another less than sign, and then 0.499. It looks fairly similar to interval notation, only with a little bit more algebraic notation. We can draw a picture to go with this as well. We could say that our point estimate in the middle is 0.447, and then on the left side we'll put our lower bound, which was 0.395, and on the right side our upper bound, which is 0.499. Our confidence area will be this region in between the lower and the upper bound. The confidence interval is the region where we believe the true proportion exists. So according to our calculations, anywhere between 0.395 and 0.499, the true proportion may exist based on our estimate of 0.447. This is a variation on the previous problem. This time we are actually given the confidence interval here of 0.455 less than p less than 0.485. And we're given this time a level of confidence. Question A asks, what is the point estimate used to construct this interval? As we saw earlier, the point estimate is halfway between the lower and the upper. So first, let's enter the information we know into Excel. The lower bound is 0.455 and the upper bound is 0.485. To get our estimate, what we can do is use the average function to find the value that's exactly halfway between them. Just place the lower and the upper inside. We'll say equals average and simply select the two numbers above. This gives us an estimate of 0.47. So if we were writing the confidence interval the way we were given it in the previous problem, our confidence interval will begin with 0.47 plus or minus the error. Now, let's find the error. To find the error, all we have to do is take the upper value and subtract the estimate. So we'll say equals the upper minus the estimate. This gives us an error of 0.015. So if we wanted to continue writing this confidence interval the other way, we could say 0.47 plus or minus 0.015. We could also draw a picture based on this. Our point estimate is 0.47, and as we know, our lower is 0.455, which we were given, and our upper is 0.485, which we were given. The distance between the upper and the point estimate is our error. Whereas from the lower to the upper is our confidence interval. Now, part C asks, write a sentence interpreting the interval in this context. Now, the definition of the confidence interval is this. We can say, with this level of confidence, that's 95% in this problem, that the true proportion of voters who do support that candidate is within 0.455 to 0.485. However, it's important in statistics to recognize that no calculation is perfect, and we could be wrong. So we must specify that we are only saying this with 95% confidence.